Welcome to this topic video on JavaScript promises. Our goals here are to understand the fundamentals of promises in JavaScript. Okay, what these things are and how we're going to use them to chain together, how we're going to chain them together to control the order of asynchronous processing. Okay, this is a technique for asynchronous programming in JavaScript. Okay, we had dealt with callbacks and events. Now we're going to go to a next step. Hopefully make our code easier to write and clearer to read. Okay, but that's going to take a little bit of effort. We're also going to see how to compose promises to give us even more control over processing order. Okay, using promises. Read this one. I've got the asynchronous examples in a zip file once again. Okay, and the reference on promises. The biggest thing is we're going to practice with them. So practice them in with the code samples that are right in the slides. Then we're going to use them. Okay, as soon as we start doing some network requests. Okay, but right now we're going to be a little abstract. So, what are we're talking about asynchronous programming in JavaScript. Okay, all this is fundamentally based on the event queue and callback functions. Okay, promises are a mechanism that's going to help refine the event queue and callback functions in a way that can make our code clearer. If you don't use them in the appropriate way, your code will look like the pyramid of doom and callback hell that we talked about before. So we're going to make sure we kind of understand and work through enough examples so that we can see how not to do that. Okay, because sometimes when people first throw promises at you, it's like, what's the difference between this and callbacks? Okay, because callbacks will be involved. Furthermore, a more advanced and even nicer reading style of programming for asynchronous in JavaScript called async and await, that builds on promises. Okay, so all these build on each other. Okay, so they give us better ways to do things. Okay, so we're going to start with this. We started with the basic event queue and callback. Now we're going to see these things called promises. Okay, so what is this thing? Okay, this is an abstract notion. A promise represents the eventual result of some kind of asynchronous operation, an operation that's going to take some time. Okay, and we don't want to block. We don't want to just sit there and wait. Okay, and not let anything else happen. Okay. The primary way of interacting with these things is going to be, it's got a method which you can register callbacks. Okay, but we're going to see with chaining of promises, we don't have to get into that callback nesting. Okay, so that's going to be key. What's the difference between this and callback nesting? We're still going to use callbacks. Don't get away from using functions. Okay. Now, how are we going to do this? Well, they do some things underneath for us, but like many things in programming, part of the way this is going to happen is through another level of indirection. Typically, we're not going to construct our own promises. We're going to use promises that are supplied to us by APIs. However, to get some practice and learn some concepts, we are going to construct our own promises for simple examples. Now let's look at this promise constructor. Okay, so here, this is built into JavaScript. So if you go over to your command window, and you type in promise, you'll see it's waiting for us. Okay, there is something all ready to go for us. Okay, this is part of the JavaScript language. This constructor takes a function. Okay, where that, okay, the executor function takes 2 arguments. So the promise constructor takes a function which takes 2 arguments, each of which are functions. Wow, that's a lot of indirection. So the promise constructor takes a function that takes 2 arguments, each of which are callback functions. The resolve callback function gets called when things work out well, and the reject, as you might guess, gets called when things don't go so well. However, we're the ones that define this function. We're the ones that define what happens in resolve and reject. Okay. In addition, okay, using this constructor, a promise has state. This is how they make the magic happen. Okay, it can be in 3 states: pending, fulfilled, or rejected. Pending meaning it hasn't resolved. We've made a request across the network and it hasn't come back. Okay, fulfilled means the operation completed successfully. Caution: successful completion of an operation may not mean it's error-free. We're going to see when we work with the fetch API and the node fetch API that sometimes the operation will complete successfully, but the result is that thing wasn't found. Okay, it just means that we got a response. The response told us that no, that thing wasn't there, versus we didn't even get a response. Okay, so you got to be little understand the API you're using, what it means to be fulfilled, and does that mean that everything's great, or does that mean you need to do a little more checking? Rejected always means something bad happened, typically. Okay, so let's construct our own promise. Okay, we can try this on the console, or you can go and run this with Node.js. They run exactly the same. Okay, so here we're going to construct a new promise. This is going to be a function. We give it a function. I didn't give it a separate name. It's defining an anonymous function in here. And what am I saying it's going to do? Oh, all it's going to do is call this resolve argument with a string saying hi web systems. Okay. Whatever, but it meets the criteria, right? New promise, we define it's a function that takes 2 arguments. We have to do that. Okay, in this case, it doesn't do anything with the reject argument. All it does is calls the resolve argument with a string. Okay, that's about as simple as we can get. Now, to use this promise, okay, after we've created it, to use it, we use it by calling its then method. Okay, we're going to go into this more in depth, but we're just going to check this out. Okay, so we created the promise. Then to get the results from the promise, we call its then method. We hand it 2 functions. Okay, the success handler or the reject handler. Professor, yes. Aren't those the exact same things yes, those are the things we're passing in here, resolve and reject functions. Hence, this resolve function better be able to take a message just like, that's like a string that we're resolving with. Oh, okay. So let's run it, just see how this works. Okay. So I know it's like a lot of complications. Okay. So new promise, blah, blah, blah. We have a success handler, a reject handler. Then we're going to call on the promise. We're going to then it, okay, to see what happens, okay. Interesting. Notice we got this output, hi web systems. But before then, we called new promise, okay? That's the only thing that we called, right? Okay. New promises is something we called, and we assigned it to myp, right? Okay. Okay. This is a function definition. This is a function definition. This is also call here. Oh, okay, down here. This isn't assigned to any variable, so it's going to return, okay, something. What's it going to return? It returned a promise state pending. Okay. Oh, state pending. Let's try myp again and take a look. Oh, no longer pending, but the state's fulfilled. Hi web systems value. Oh, so something kind of interesting is going on here. Little stateful things going on here. Right? It's kind of doing something. And we're seeing this pending phase, and we're seeing a fulfilled state. Okay, good. Okay, more on then. Okay, we use the then part. So we create, when we're handed a promise, okay, not what, okay, we're creating something to play with. But we're going to be handed promises when we call like a fetch API to go get data from a server or something like that. We're going to get the data actually from that by calling its then clause. Okay, we're going to give it a function called, okay, to be called when it's fulfilled, and we better have a function just in case things get rejected. Okay, if you don't give the thing a rejected reason, it's going to throw an exception. Oh, are you saying this is kind of like exceptions? Yeah, it's kind of close. We're going to see more about that when we get to async and await. Let's try and get a little bit more interesting here. Okay. Here we're going to create a promise, okay, just like the old one, except we're going to delay for 5 whole seconds, okay, 5 seconds. We're going to set timeout 5 seconds, then we're going to call the resolve, okay. We have the same success handler, okay. Now we're going to call P, then success handler. Okay, so let's copy that. Copied. Paste it all down. Get ready to go. Let's make this so we can see things. Okay, one thing I'm going to do while we're waiting. Okay. Right when we're waiting, we have 5 seconds for this thing that's supposed to resolve. I'm going to type in myp to see what things are happening with it. Okay. So here, new promise. I'm telling you we're using the set timeout. It's not going to resolve. Okay. So that's going to create the promise. Then I'm going to go myp then. This is just the definition, function definition. Okay. Remember, we're talking microseconds to go from here down to here in code. Right. It takes longer to log the console than it does to run, than to execute that code. Okay. So I'm going to start this. Okay. We don't have anything at the text here. Okay, so web systems, hi web systems, what should happen first? Let's think about that. But first, run it. I was called myp, promise state pending. Ooh, okay. Hi web systems, let's look at myp again. Promise state fulfilled. Okay, so it did take some time to resolve. Okay, and we notice that what was the order of things? Okay, I was called, this console log was called after myp then. Okay, so here we executed the promise, or we thened it. We didn't execute it. It was created up here. Okay, so that's when anything would start with it. Okay, it's here that we said, let's get the results. Okay, the thing was, we see this printed out. Okay, I was called after this line here. Okay, this is asynchronous operation. This is making a trip through that event queue that we talked about in the previous asynchronous JavaScript lecture. Okay, hence there is no blocking in here. Okay, I create the promise, that gets called. This function gets created, this gets called. Okay, then this line gets printed out. Every time you do something with a promise, you can guarantee it's going to take a trip through the event queue, or longer. Here we had to wait a long time, 5 seconds to resolve. Artificial, I know, but we'll see things take hundreds of milliseconds, or almost a second, if we call on a remote enough web server. Okay, so a little more interesting. So we got to see the promise in 2 different states. Okay, once again, and we notice that there was no blocking. Okay, we ran each of these pieces of code. Okay, just because I said my p then, nothing we didn't wait for this to happen. Okay, we went straight to the next line, and then when the promise resolved, the success handler got called. Okay, it's like we jumped back to this line after the thing got resolved. Okay, asynchronous programming, no blocking. Where's the blocking come in? In these handlers. Everything, once we're in a function, it's run to completion. Okay, can we do the reject path? Let's check it out. Okay, because getting used to this notion, it's like just try these things. It's a different form of programming, I know. So try it. Okay. So here, new promise, resolve, reject, promise. Oh, this one's going to call the reject function. Here's my success handler. Here's my reject handler. Okay, let's see what happens. Something bad happened. Did something really bad happen? No. We chose to call the reject path. Now, usually, you would call the reject path when something bad happened. We were just testing it out. Okay, so far so good. Now, Professor, this seems like a lot to do about nothing. Let's try something. Can multiple functions listen on a promise, in a sense? I'm calling it multiple listeners. Can multiple functions get stuff from a promise? Here's what we're going to attempt. Here we're going to have a simple resolve path, just going to say iWeb systems. We're going to try and use it twice. My p.then listener1. Okay, so here's a little built-in function I wrote. Function message is console log it, listener1, listener2. Doing that same little thing where I say called after my promise then. See, check that ordering. Keep that in mind. Can two items, okay, 2 different calls, 2 different callbacks on the same function, same promise. Sorry. So I'm going to try using then twice on the same promise. Can I do this? Okay. Let's watch this run. Called after. Oh, that's right. Whoa, that worked. We can listen to a promise as many times from wherever we like. That's pretty neat. Yeah, Professor. Yeah, it's neat. Okay. Why are we doing this? Oh, we forgot about the catch thing. Okay. An alternative for listening for rejection is we're going to use a catch clause. Okay. It deals with the rejected cases only. Okay. So instead of going then like this, undefined and unrejected, we're going to use a catch clause. Okay, so here's reject. Notice this type of functionality. My P then doing something, or catch. Okay, catch clause. Just going to make our programming nicer. Okay, because we're going to have catch clauses every time we deal with networks. Okay, something bad. Okay, so we're able to separate the then stuff from the catch stuff. Nice. Okay, it's just stuff to help us make our programming neater. But we haven't done anything yet. Don't worry. We're going to get to it. We're going to be up to our ears in this. Okay, we're going to be using this on the server side too. Okay, every time we go and talk to a database, okay, we want those operations to be asynchronous so we don't block. Okay, Node.js is particularly good at this. Okay, that's how I was able to catch up to all these more sophisticated, closer to the metal languages because it doesn't block. You don't have to block, and they built that in. Okay. So this is starting to feel a little bit like events. Okay. We would register event listeners for specific types of events, right? We would add listeners and add listeners. Okay. So we're able to do that with promises. Okay. There's no limit the number of times we can call that then clause and hand it another function. Okay. Now the question is, we know we can miss events if we don't register for them in time. Can we ever miss a promise if we are late to check it? Okay. So here's my example. Late to the party. Late to the party JS. So what am I going to do? I'm going to have a promise. Okay. And it's not going to resolve right away, but I'm going to have it resolve in a tenth of a second. Okay. All it's going to do is say hi web systems. Okay. We're going to check on the promise much later. How are you going to do that, Professor? I'm going to set timeout. Okay. In this case, okay, what's it going to do? After 3 seconds, this function is going to get called. What's this function do? It goes my P then. I know this is getting functions within functions. You said we're not going to do so much nesting. This is for learning purposes. Okay. So after 3 seconds, we're going to then the promise. Okay. So we're going to then print out from listener 1, blah, blah, blah. See if we can get that message. Okay. Then we're going to try it again. Okay. Do these run one after another? Yeah, they run right away, but remember that this one's delayed for 6 seconds. So this is going to happen after essentially 3 seconds. This is going to happen essentially after 6 seconds. Okay, so much later. Okay, copy that. Copy it. Oops, not there. Paste it. Okay, what's going to happen? Can we miss the promise? We're going to get a big error message. 1, 1000, 2, 1000, 3, 1000. Hey, we caught it. Whoa, we caught both of them. Okay. So even though we were late to check on them, this promise resolved in a tenth of a second. Even when we came 3 seconds later, okay, we were able, okay, you can't miss a promise. That's the, okay. Now, here's where we get to more interesting things, okay. We can modify promises and return them, okay. Modify them. What do you mean by that, Professor? Modify what? Okay. So here, we've done this before. Here's this promise. Hi web systems. So it's going to resolve after 3 seconds, 3,000 milliseconds. Okay. We're going to go then. Okay. Function, message, return, I saw message. Oh, so this is going to return. I got this return value. I'm not just doing a console log. I'm actually returning something. What's this going to do? What is P2 going to be? Is P2 a promise? my P2 instance of promise. Then I'm going to try thenning my P2 and seeing what it does. Okay. This is going to be very useful. Okay. I know it's abstract right now. Okay. Is P2 a promise? True. Okay. I saw high web systems. Let's go back to the code over this side. Analyze what happened here. Okay. My P2. Remember, promise gets created. This line gets executed. At this point, this has got a value. What's its value? It's a promise. It's an instance of promise. Nothing's got resolved yet. Okay, because we're waiting 3 seconds. So all this code is going to be well finished before the promise resolves. If we then it, and we say function message, what's it going to say? Oh, over here, we're going to return, given the message that we received from the first promise, my P, we received, this guy's going to return, I saw this message. He's going to return a new message, a modified thing. Okay? It comes out, though, first, because this line has to be able to execute, because this code has to be able to execute, because it's just a function call. This is going to become a promise. So he doesn't resolve right away. He's going to be a promise. Then I can get at him. It's returning modified promises. When we study, we're going to go look at chaining in more in depth. It's by returning these modified promises. This is how we're going to avoid nesting. Okay? Okay. So if you're working with promises and you start having thens, and then you have thens, and then thens, and then thens, you're doing something wrong. Okay? Because we can return promises. Okay? From thens. Okay? So, what have we learned so far? We can listen to promises at multiple places. We can never miss a promise. We can return stuff from the then clause of a promise, and that becomes a new promise. Okay? Why bother? Okay, once again, web programming involves significant time delays. And what do I mean by significant? Remember, your computer is running in hundreds of nanoseconds and microseconds of instructions. Okay? So, a tenth of a second or 100 milliseconds across the network, can feel like a long time. Okay, or waiting for a database server to respond can feel like a long time from the point of view of code. Okay, the strictly event and callback paradigm, the event-based paradigm, like we learned before, can lead to this callback hell problem. Okay, too much nesting. Promises can help. In addition, many modern APIs return promises. Fetch is one that we're going to be using a bunch. Okay, so let's see about chaining these. Okay, how can we use promise to help us manage asynchronous execution? Ooh, remember the silly clock from the previous lecture? So let's going to try it. Okay, so let's review that real quick. Okay. First of all, we saw that this wouldn't work. Okay, I've got this little advanced time function. Okay, and I wanted to advance time to make my own little clock, and I wanted this to print out each time, and I compare it to real time that I get from the date function. Every time I call new date, I get the current time according to my computer's clock. Okay, so here I've got my time variable that I start off at 0. Okay, when I start this thing, I get the date, and then I keep getting new dates and subtracting. And since that's all in milliseconds, I divide by 1,000. Okay, if I copy that and run it like we did before, we see it doesn't really work. After the first second, okay, all these things evaluate all pretty much at the same time, because each one of these functions adds this, each one of these set timeout calls adds the advanced time function to the event queue, each with a 1 second delay. These aren't chained together in any way. If we want them to chain together, we saw, okay, that we need to nest these set timeout calls, okay? So here's set timeout, here's a function, we call another function set timeout after we're done doing those things, okay? That one we nest together in yet another timeout, and okay, and you can see here is start of our, what some people refer to as the pyramid of doom. But does it work? Ugly. 1, 2, 3, 4. It does work. Can we do this better? I hope so, Professor. You made us learn all about these promises. Sorry, I have to talk to myself because you are not here right now. Let's go and see. Okay, let's see if we can do better. Okay, let's do a promise. Okay, so my time, start time, beginning from before. Now I'm going to have a function. It returns a promise that resolves in 1 second. Function 1 second. Return new promise, blah, 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 blah. Function advance time. What's this going to do? It's going to advance time. Oh, and it's going to return another 1 second promise. So the question is, what's this going to do? Okay. So after the first promise, I'm going to say 1 second. And what's it going to do? Returns a promise. That thing's going to resolve. Okay, then I say advance time. Advance time. Ooh, it's going to return another promise. And then, I don't see that nesting, but it feels like it's nesting. Let's see if this works. Okay. Okay. Big long code. But down here, when we finally get into it, see how this works. 1, 2, 3. Now, is this a little tricky looking? Yeah, we're turning a promise that results in 1 second. So this is like a 1 second timer for us. Okay. We created this 1 second promise, this function that returns promises that resolve in 1 second. Okay. And then we use it. Okay. But did we have to, we didn't have to nest. We didn't have to nest super deep. So we're getting a little payoff. Professor, yeah. How else could we do this? Well, we did that chaining thing, but we can also do it this way if you don't like that. Okay? Remember, every time we call then and return stuff, okay, we're returning something here, we're creating a new promise and a new promise. Okay? So we can work this way. Okay? Let's take a look that this runs like the previous example ran. Okay? We're just creating new promises and running. Okay. Okay. We just didn't go as far. And we're going to get more involved with these things once we get to networking. And we're not going to have to create our own. Okay, so first thing we're going to do after we learn our HTTP is we're going to make our own requests that the library, the fetch, is going to return us promises. And we're going to look at those. Okay. Now sometimes we need to do things, okay, where we want to wait for everything to resolve. Okay. So we want to go talk to a bunch of websites, and we don't want to do anything until we get the data from all those sites. Okay. We're going to somehow be gluing all those things together. This is a place where we might want to use promise all. Okay. So this is a lame example. Okay. But here we create a bunch of promises. Okay. Artificial, I know, but we don't need any other software or tools to do it. We don't have to worry about cores or any things that we might have to deal with browser fetch. Okay. So I create 3 different promises. They all resolve in different times. So I put them all and pack them into an array. Then, okay, oh, I'm going to look at one of them by itself. I'm going to go then, message, constant log, see what it returns. Then, what am I doing here? Promise all my p's, this array of promises. Okay, we're going to wait on all of them to resolve, and then we're going to print out a message, whatever that's going to do. Okay, so let's try it. Clear that up so we can see it run. Make it even bigger. Okay, so what we want to see is the behavior down here. Okay. Notice, to get anything out of this combined all promise, I still have to use this then clause. Just like if I wanted to get stuff out of promise 1, I use the then clause. I from P1 is resolved quickly. 5 seconds later, then I get an array of all the returns from all the promises. So in this way, I was able to wait for all of them to finish. Well, that's handy. Okay. We could also think about this as letting each one of them run in parallel. We didn't chain them together. We're not running them one at a time. That would take 1, 5, 6, 8 seconds total. But in this case, we let them all run at once, and we waited till they all resolve, which is only about after 5 seconds. So that's like running things in parallel, and that's what we're going to illustrate later when we do requests to web servers. Okay. There's another way. Okay. Promise race returns a promise that resolves or rejects as soon as one of them. Okay. Racing requests. Okay. So who's going to resolve first? Well, Professor, you put in real numbers here. You could have put in random numbers and it would have been fun. Okay. But we know that P1's going to win because he's got the shortest time. Okay. My P's, I take all these promises, create them. They're all going to resolve after different amounts of time. 1 second, 5 seconds, 2 seconds. I pack them all into an array. Remember, all this happens in microseconds, okay? Because we just execute each of these pieces of code, right? These things get put on event queues and such like that. Magic's going to happen to make those happen at other times. Then we say promise race, okay? This thing, promise race, is a new promise. Its behavior is to resolve as soon as one thing resolves positively, okay? So we then it, okay? Let's copy it and try running it. When would you use this thing? When might you use this thing? The winner is P1. Oh. I'm tired of P1 winning. Let's come here. Let's chop this down to half a second for P2. Run it again. The winner is P2. When might you use this? If you're in a performance-oriented situation, or you're working with a bunch of servers, okay, that return similar results, you may make a request to multiple servers all at once. And as soon as you get results from one, that's good enough. Okay, you won't bother waiting around for the other ones to deliver. I know that sounds inefficient as far as computational resources, but it depends on the goal you're trying to achieve. Promise race. Okay, all right. Now, promises and Node.js APIs. So the event queue model with callbacks, okay, allowed Node.js to achieve very good performance, okay, for both file system and network operations. Node.js uses an event-driven model for file system and all its network operations, okay. It allows it to be very performant and scale very well, okay. However, this requires the use of callback functions all over the place. Okay, go look at the DNS and file system API documentation. Wouldn't it be nice to have a promise-based version of these APIs to simplify our code? Especially since we're going to see once we have promises, we can get async and await. And if we have to do things one at a time, async and await style programming is the prettiest, cleanest looking stuff. It's based on promises. It's no different than promise chaining, okay? But it's nice and clean, okay? So Node, we're working in Node. Node has a bunch of features. They're all based on callbacks because that's how Node got started. Then promises came later and got standardized. Oh, would you believe there's a utility in util called promisify, okay? Util promisify original interface, okay? The original is a function interface, returns a function, okay? So that means ugly callback-based file concatenation. So let's say we're trying to be very good and we're going to use the asynchronous read file, not the sync read file, the asynchronous. And say we want to read 3 files and glue them together in the order in which we read them. See this nesting going on. Nesting the callbacks to make sure we get the proper order. And think about what happens if we had errors too. We can go in and use this promisify. Promisify? How you tell me how to pronounce that. Okay, so here's read file promise. That's what I'm saying there. So I'm promisifying the read file interface. So look at this. Read file promise, then return. Oh, I'm returning those promises and reading the next one. Nice, easy way, okay, to do things in order. Can it get easier? Okay. I'm just going to give you a quick sample. Here's an approach using async and await. Okay. Notice we have to wrap this stuff in an async function. Don't worry, we'll cover this later. Okay. An asynchronous function. But look at this. Try, catch, standard exception stuff. Then we just say await, read things. This will really make things happen in order. However, it's not blocking. Other things can go on, because this is using event-driven callback functions with promises on top to make it easier programming, with this async and await syntax we're seeing here to make it even easier. It looks like we're just saying, do this thing, and I'm going to wait for it, do this thing and wait for it. However, it's not blocking. Okay. Key. Okay. So this is a Node thing. Okay. We can use the existing Node interfaces and turn them into promise-based interfaces. Okay, we're learning promises. Let's get as much value out of them as possible. All right, see you on the next time.